So in the last video I showed you how the compiler takes this anonymous type and actually generates a class. The compiler also does a few other convenience things for us, but things that we actually rely on, especially when we do some hashing, some grouping. Okay, when we group data as in link, as you'll see in future videos, we actually need this functionality. But it's not too far out there, not too technical. Let me show it to you. First of all, I'm going to right line my instance. Okay, the compiler generates a nice intuitive toString for us. So instead of just printing out the type name of this class here, we get first name equals Jamie, last name equals King, in the curlies. And the curly, it kind of denotes a tuple. Ooh, tuple word. If you're not familiar with tuple, it's basically a way of saying a data object. It's key value pairs, right? First name Jamie, last name King. I can stuff as much of those pairs as I want to in here. It's a tuple. In this case, we have a two-tuple, Jamie, King. Anyway, all right. So nice intuitive toString. Just while I'm at it, though, I'm gonna do a get type here, just so you can actually sample the type that the type name that the compiler generated for us. So I guess the compiler called it angle bracket f underscore anonymous type 0 tilde 2. The tilde 2 means it's a generic type actually, which I'll talk about not in the not too distant future. But basically, it's a generic type, stores two strings. Okay, so let's go here and something else I can say is console write line instance dot get hash code. Okay, the compiler overrides get hash code for us, and what it does is it relies on the get hash code for the data members. So string, fortunately, overrides get hash code for us, and then ints and chars and doubles, I think they just return their own value for hash codes. But basically, if you're going to use this thing for hashing or grouping or anything like that, then we get a nice intuitive hash code here. Let me show you. Get hash code. The number here is -52835, yada yada yada. And we could maybe I'll show you all this in the reflector. The compiler implements that. But notice the get hash code's nice. In fact, I'm going to make a instance and an instance 2. Right, and let me get rid of that one there. And let's do a instance 3. On an instance 3, I'm going to say Billy King. I don't know if I have any relatives named Billy, but Billy. So these two instances have the same values for the first name, last name. But then this third one has Billy King. All right. So I'm going to print Control L, Control V, V, V. We're going to call this instance. Call this instance 2, instance 3. So if what I'm telling you is true, the get hash code value for both instance and instance 2 should be identical because the data members here are identical. But the get hash code for the third value here should be different because this has a Billy here. So let's run that and view it. Ah, how nice. Okay, now it doesn't really matter that this value is negative. This one's not. There's different hash codes, and that's just how that algorithm works. So that's good. I can hash on these things now. Okay, another convenience method the compiler overrides for us is equals. Okay, so I can say instance dot equals instance 2. Okay, and if you look, equality is just based on the data members here being equal, and that's actually relies on the dot equals, not the double equals. Dot equals is polymorphic, whereas the double equals is not. It's just static, so it doesn't do a reference comparison. It actually, asks these property values. Hey, are you equal to him? And are you equal to him? Well, in this case, that should be true because instance is equal to instance 2. Right? There you go. True. But then if I ask instance if it's equal to instance 3, well, no, this is Billy. So we actually get false there. So that's kind of nice that the compiler gives us a get hash code, it gives us a toString, and it gives us an equals. Let me just use the reflector to kind of show how this is all done. I'm going to boil this down to just main there. Let's pull up the console here, use my batch file to open the reflector and see what the compiler actually did here. If I go into main class, okay, here's the generated class, this F anonymous type. Notice it's full of stuff here, but I named the field first name field. Oh, it's generic. I'll talk about that in the next video why that's generic. But basically, there's our strings, and look, here's over equals get hash code to string. I'm gonna hit expand methods so we can kind of see what the compiler wrote for us here. Okay, drag that out there, and then see, hey, look, get hash code int num some num. I bet it doesn't really look like anything I can recognize in hex, but then it does. I'm not even gonna try to figure out their algorithm here, but basically they're making a hash code for us based off the fields. Let's see, equals. It looks like it's using equality compare. That's a good thing. It's checking for equality on the first name, and then we should see equality compare. Yep, equality compare on the last name. So it is relying on the equals method and not on the double equals operator. ToString, pretty straightforward. Make string builder, append first name, last name, return the value that was made by that string builder. And then look, here's the properties, and then here's the backing fields. All that stuff. Compiler generated just for us. Very nice. Anyway, that's anonymous types in a nutshell. Not too, there's a lot going on, but they're really useful and really convenient, and we use them a lot.